Yeah, once again, good afternoon. We know we are discussing about dictionaries. Here in the dictionaries, already we discussed in the last class a linear list representation. That linear list representation we can implement two ways. One is using array. Another one, using array means sorted array. Another one is the sorted chain. We talk about using linked list. Now, can anyone tell what is dictionary?
Collection of key value pairs.
Collection of pairs. Each pair contains key and data. Correct? Yes or no?
Yes, sir.
Yeah. Now, in first unit we discussed about only the linear data structure, but it is not sufficient when the data is large. When we are going to search one particular element, it is taking more time. Yeah, that is the reason here we implemented a dictionary data structure. It is going to avoid that searching with help of key. We are going to search that particular element somewhat faster. Correct? Correct. Yes.
Yes.
Yeah. Yeah. Now, for that dictionaries implementation, so many applications I told you in the last class. Along with that, we discussed about using sorted array. Means the array you can use and you can implement the data structure of dictionary. Here it is nothing but array. Here the indexing is a keys which are in a sorting order, and we can store any value based on the index. That's why we are calling it as a key. Yeah, the drawback of the sorted array is it is a static nature. That's why we cannot insert more than the size. That is the drawback, you know very well. Here to avoid that case, they implemented sorted chain. Here, chain is nothing but a linked list. Here, node is divided into three parts. Now, one is key part, one is the data part, next one is the next. We know here in this dictionary, along with data, we need key also. Means through key only we are going to perform whatever the operations you want to perform. Here in the last class, we discussed about insertion, deletion, and searching and display operations. Correct? Yes or no?
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah. Now, today we are going to discuss about skip list. Here, for that, actually, in your syllabus, they are not mentioned performance evaluation. Actually, one topic is very important. R16 regulation, R17 regulation, that is there, but they are removed that topic. But that topic is very important. Yeah, that is there in your next year DA subject also. But at least I will give some idea because this based on this topic you will get so many questions in gate and interviews and everywhere it is going to touch. So that's why before starting this skip list representation, I'm going to discuss about performance evaluation. Please, this is very important. Don't feel it is not there in the syllabus. Why should we? No, no, it is very important. Okay, performance evaluation. This topic is actually very important. Please, everyone concentrate and understand. Sure, everyone is mathematical background student, right? Then you can understand very easily. Here, when I will ask to write one program to all the students, if I ask all the students to write one program, for example, addition of two numbers, everyone will follow same set of instructions, or different people will write different ways. Are you clear what I am telling?
Different people will write in different ways.
Because different people will do different way. Because for example, some people will ask end user enter A value and B value, and they will show result as a C equal to A plus B. They will print. Yeah, some people will ask end user enter A value and B value in two different printf statement, different scanf statements, and they are going to print directly. Print sum is A plus B. Yeah, like that. Some people will take directly without A and B. They will take constant values and they will print printf 3 plus 4 like that. Are you clear? Yes or no? Yes or no?
Yes, sir.
Right. Very good. Now, different people will write different ways. Now, which one is the best? If I ask anything, if you are going to write algorithm, you know step-by-step procedure is the algorithm, you know in your first year, correct? Do you have algorithm in first year?
Yes, sir.
Yeah. Algorithm is about step-by-step procedure, right? Everyone, they can write their procedures in different ways. Now tell me out of, for example, I given one question in your class, 60 students are there. The 60 students are did their solution in different ways. Now, how should I consider which is the best, or how should we consider which is the best? Tell me. Please listen carefully and respond. Then only you can understand what really I am trying to explain. Tell me now. Sir, which one is the best? For example, I will tell you. You know Secunderabad railway station, right? Everyone knows Secunderabad railway station, right?
Yes, sir.
Yeah, from Secunderabad railway station to CMRTC. You are going to move from Secunderabad railway station to CMRTC. Sir, how many ways? I will tell you all the students. You must from year two you move to Secunderabad CMR Technical Campus. Then I don't want to tell which thing you have to do it. You have to reach. That is the thing I will tell. Then tell me, different people will take their different resources and different paths and different things. Finally, they are going to reach. Then how I can judge which one is the best to students he has reached to CMRTC? Based on what? Anyone?
Sir, based on time.
Based on time? Only time? In that case, only time?
Distance.
Distance? Here, everyone is right. Don't hesitate to tell answer. Here, everything is right. This is general question I am asking. Distance, time, and only two parameters. Means distance means less distance, less time, and
More speed.
yeah, less distance, less time means more speed only, and less expensive. Sir, expenses. Yes or no? Yes or no? Expenses
Yes,
means
sir.
some people will take a flight, maybe the chartered flight they will book. More expensive, right? That is also very important for this case. Generalized statement. Yes or no?
Yes, sir.
So now, my question is very clear here. Here, now coming to the task, one program I will give it to you. You write. Now, how can I consider which is the best effective program, best performance of the program? How can I know? Based on what? Now tell me.
Sir, which takes less time to execute.
Very good. Which the program which is taking less time to execute. Only one parameter. Is there any other parameter?
Sir, which uses less memory.
Yeah, these are the two important parameters. One is less time to execute and less memory to execute. That program is the best program. You can tell that is a good performance of the program. That is the performance. How we are going to calculate which program is having how much performance it is having, how we are going to calculate what program it is the best based on only two parameters. Yeah, that is less time to execute the given instructions and the program which is taking less memory. Correct? Correct.
Yes, sir.
Then how we know how we know which program is taking less memory, less time of execution? Yeah, because nowadays everyone is using different machines to execute their programs. Yes or no? Yeah, these two parameters are right 100%. But come to the reality. All the users are using same machines,
No, different.
means different configurations they are using. Yes or no? Yes or
Yes,
no?
sir.
Yes, sir. Yes.
If different configurations people are using, the meaning is what? Here, one system is going to work more fast because of their configuration. Some other systems are maybe the slow because of their configuration. Correct.
Yes.
Yes or no?
Yes, sir.
Yes, very good. Yeah, this is one problem. When you are going to use only directly, we can take all systems in one criteria. If you take, it is not good idea. Correct? Is it right? Is it right or wrong? I'm using i7 processor. You people are using maybe i4 processor or maybe Celeron processor. Both speeds are same.
Different. Yeah.
Different. Same program, different machine. It is running different speed. Yeah, that is not a program problem. It is a machine problem. Yes or no?
Yes.
Yeah, this is what exactly we cannot judge based on this mechanism. And one more point I can tell you here. Here and that editor also very important. Now I am going to use dev C++. Some others are using maybe the ANSYS or any other turbo C. Both are different editors or not? Different compilers or not?
Yes, sir.
Yes, compiler to compilers, maybe the memory management and operating. One more thing also I can tell. Operating system also different. I'm using Windows, someone using Unix. Here, different or not?
Yes, sir.
Yeah, that's why
Difference.
based on that's why based on these parameters we cannot find the performance of the program. Only these two parameters it is not sufficient. Yes or no? Yes or no?
Yes, sir.
Here for that, here our computer science people they provided three notations for measuring of the performance of the given task. Here that is big O notation, actually big omega notation, big O notation, and big theta notation. These three notations are very, very important for performance evaluation. Here, instead of taking time and speed, we cannot measure the program performance because different people are using different machines and different people are using different softwares to run our task. That's why it is different. Yeah, then how to measure that particular program performance? Only mathematically they give an actually some theorems are there, but it is not even this topic also not there for you. But I am giving some idea because very important. Next chapter onwards, how to calculate. Sometimes people will ask in examinations and gate and interviews your placements, all these things. That's why I am giving idea. Now, what is this big omega, big O, and big theta? Nothing but theta, O, and omega only. Just you have to write somewhat bigger, then that is big O, big omega, big theta notations. First of all, clear this? Sir, why these notations are required? Because different people are using different machines. Different machines are using different software, different operating system or softwares to perform your task. That's why it is not possible using speed and memory usage. Correct? Correct. Are you clear? Hello?
Yes, yes, sir.
Yeah. Earlier, actually, one topic is there half of the unit for performance evaluation only, but they removed. That is why just I am giving the idea. It is very important. Any other time, if you really want this, this is very important actually. Any time in your software industry, also when they want to write, they are going to choose the best program based on this performance evaluation only. They will do. Sir, any other time, any free slot, then we will discuss. Don't worry if you want. You remind me later, then I will discuss completely. Right. Here, big omega, big O, big theta. Here, big omega will tell here minimum required time. Are you clear? This is minimum. Big O means maximum time. Big theta is average. Please remember these notations. I will tell you why. Why I will tell you. Actually, so much of theory and theorems and solutions are there, but in your syllabus it is not there. It will take 5 to 6 hours to explain completely with examples. So that's why I am giving one idea. So anytime it is required, I will tell you with separate classes. Okay, right. Now tell me, big O means minimum, big O means maximum, big theta is average time required to execute the program. Now, how minimum? I will tell you. If you ask me, sir, when you come to college, means I will call you. You come to me like that. I will ask you. Then you said, okay, sir. Then I will ask. Tell me what is the minimum an hour before you will come. So that is minimum, right? If you tell 10 minutes, means I never wait after 10 minutes. I will wait up to 10 minutes only. Are you clear? Hello.
Yes, sir.
The meaning is very, very important. Please understand. It is very important. I am telling, without this performance evaluation, there is no subject. Please. Here, these are mathematical notations. Here, big omega is for minimum time required. Minimum time required. That is called, the representation is big omega. Now, simple example is, for example, I am going to give one operation, A plus B. If I ask you to solve this, everyone will tell, yes, sir, we are going to solve like that. You are answered. Then I will ask, tell me what is the minimum time we are going to solve this? What is the minimum time we are going to solve this like that? If I ask you, you will tell 3 minutes. Are you clear? Hello?
Yes, sir.
Yes, sir.
Means after 3 minutes, I have never consider any solutions. Any answers from the students. The students who are given only before these 3 minutes only, I am going to consider their marks. Are you clear now? Are you clear now?
Yes, sir.
Please understand the point. This point is very important. Just I am asking, here tell me what is the minimum time to solve this problem. Here you are given 3 minutes. Then I am going to ask everyone. Then before 3 minutes only I will ask. Okay, maybe 30 students are going to solve, remaining 30 is not solved. Correct? Maybe if you feel like that. Now I will give marks for this 30 only, this 30 I cannot give. Means that the minimum time of this performance is 3 minutes. I will consider. Then only 30 students are going to solve. So this is what minimum. That is a big omega notation. Are you clear? Are you clear?
Yes, sir. Clear.
The same problem I am given, A plus B whole square only. To solve this problem, then what is your maximum time? What is your maximum time means? You told me 5 minutes. Means sir, I never consider this time. Here, I will wait up to 5 minutes. I will wait up to 5 minutes to solve the problem because maximum time. Maybe even though after 4th minute, 60 students are solved the problem. Even though I have to wait 5 minutes. Yes or no? For example, when you enter into the examination hall, you people are having 1 hour time for writing of mid-examination. Clear? But compulsory 1 hour, it is mandatory. Then I have to wait until unless the time is going to finish. That is the maximum time. That is the representation of big O notation. Are you clear?
Yes,
Are you
sir.
clear? Yeah. Now the last notation is big theta notation. It is average. So what is same problem? What is the minimum time? What is the maximum time? What is the minimum time? 3 minutes. What is the maximum time? 5 minutes. Yeah, this is average. If I tell me how much time you are going to take, what is minimum time, what is the maximum time I have to wait, then only I will wait. Like that, if I ask, you will tell, sir, minimum you wait minimum I will come within 3 minutes, otherwise you have to wait 5 minutes. Means you are given one range, that is 3 to 5. Means 3 to 5 means here before 3, no one will complete. Okay, no one will complete. This is the meaning. Average means compulsory. Everyone is required to complete the task 3 minutes, and the maximum time is 5 minutes. This is the meaning. Understand? Minimum 3 minutes means here before 3, no one will complete this task because it is required minimum 3 minutes of time to solve the problem. Compulsory. Before 3 minutes, no one will solve. Here 5 minutes means everyone will solve on or before 5 minutes. Here before 3 minutes, no one will solve that problem before 3 minutes. Here average is nothing but here it required 3 to 5 minutes to solve the problem. Understand? The minimum is 3, the maximum is 5. Here this is the average. That is big theta notation. Clear, everyone?
Yes, sir.
Clear, right? Clear, right?
Yes, sir.
Yeah, very good. If you are clear, then you have to tell. Now, here, now this is what? What is this? What is this? Linear representation of dictionary. Yes or no? Yes or no?
Yes, sir.
Now tell me, I want to find the 8 key node in this linear representation. Then how many comparisons are required? How many comparisons are required? Confusion. Don't feel this big O, big O. Generally, you tell how many comparisons are required here. I want to find this node, the node which contains key value is 8. How many comparisons are required? From where we have to compare?
Start.
From start. Here until?
And
Now
last.
tell me how many maximum comparisons are going to require here?
4.
After 4 only you can tell that element is not there. Yes or no?
Yes, sir.
Here now tell me, in this linear data structure, here this particular dictionary contains n elements. Then I wanted to find this 8. How many comparisons are required? How many comparisons are required? Hello? This dictionary contains n elements. Then how many comparisons are required for this 8?
And N, sir.
N. For example, the K is K. Now I want to find this K. How many comparisons are required? It contains n elements. N comparisons. Means maximum is how many nodes are there in the dictionary? That is the maximum, right? Yes or no?
Yes, sir.
Yeah, that's why here when I'm going to consider the performance of this particular program with the given text, the maximum is what? Big O notation of n. The performance of this linear representation for the sorted chain is big O of n. Always we have to take big O notation. This is the better industry norms. We have to take big O notation because always you have to go with the maximum. So some people will take mean and average, but this is the good notation. Big O notation is the very useful notation. So always we are going to consider big O of n. N means how many nodes are there here? How many nodes are there here? Hello? How many nodes are there here?
4. 4.
4. For 4 comparisons, we can tell this node is existed or not. Maybe K, maybe 9, maybe 5. For example, the key value is 5. Then how many comparisons are required? How many comparisons are required? 1 and 2. Correct? Yeah, today what happened here? You are in right mood or not? So I wanted to find 5 key values 5 in this dictionary. How many comparisons are required?
4.
Huh? How many comparisons are required?
2 comparisons.
5 is the third.
2 comparisons, sir. Who is this? Where is the key value of 5?
In the third node.
Then how many comparisons are required?
3.
3. 1, 2, 3. Right. What is the linear data structure performance? Big O of n means maximum. How many comparisons are required? And how many nodes are there? Here, how many nodes are there?
4 nodes.
4. The maximum is 4. But when you are going to search 5, here, how many comparisons we are going to found? 3.
3 comparisons.
Yeah, that's why here we are given 4, but it is done with 3 comparisons only. Here we are telling end user for this data structure, it is taking big O of n. Even though if you write 9, even though if you write 100 also, how many comparisons we can tell that node is existed or not? In this data structure, how many comparisons we can tell? How many comparisons we can tell this node is existed or not?
N comparisons, sir.
It means this dictionary, how many nodes are there? It
4.
means 4. Yeah. You will give any number as a key in this data structure, in this dictionary data structure, it will tell, or maybe the linked list data structure or any data structure, it is a linear data structure, right? If it is a linear data structure, it contains the performance evaluation is big O of n. Means the big O means maximum upper bound. Big omega is nothing but lower bound. Theta is nothing but average. The upper bound, the maximum 4 comparisons or maximum n comparisons, we can found that particular element is there in that particular linked list or dictionary or not. Are you clear now? Are you clear now?
Yes, sir.
Now it is
Yes,
not
sir.
depending on the machine, it is not depending on the software, it is depending on your representation of data structure. Any machine you can take it. Here, any machine you can take it. Just we are going to tell big O of n. The linear data structure, whatever you take, any element if you want to find, it is maximum, means the maximum is n. That is nothing but a big O of n. Big O is nothing but a upper boundary, maximum of n. Understand this representation now? Understand?
Yes, sir. We did.
Yeah.
Yes,
Now this is very important. Anything is there, you ask me. Every time I will ask like that only. Please, very important. So many areas we can use. Now, Today we are going to discuss about the skip list. Before discussing skip list, what is the disadvantage of this linear representation of dictionary? What is the disadvantage? Tell me, anyone? In this linear representation of dictionary, what is the disadvantage? Then we'll go with implementation using skip list. Any disadvantage anyone is observed?
Need to compare. We need to compare n times.
In this representation also, like linked list, here also we have to compare all the elements. The time complexity is how much? Big O of n. Understand? The complexity is how much here? Big O of n or not?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Means within single comparison or two comparison, we are not telling. Means the idea is my dictionary contains 1,000 elements. Then how many comparisons are required to find one particular element? Average on our upper boundary. Don't tell minimum, don't tell maximum. Only you choose upper boundary, means big O notation. How many comparisons are required? How many comparisons are required? Huh? How many?
1,000, sir.
1,000 comparisons are required, exactly, because it is a linear structure only. So this is the big drawback. Even though we are given keys for every data, also here it is taking the time complexity is big O of n, means how many number of nodes are there in that particular dictionary, that many comparisons are required. Then there is no use of linear representation for the dictionary. Yes or no? Even single linked list also same, even arrow also same. Then it is not a good idea. Correct? Correct. Please, if you understood, then skip list you can understand very easily.
Yes, sir.
Understood this now? Why this linear list representation is not good thing for dictionary? It is taking big O of n time complexity for element search. Yes or no?
Yes, sir.
Yeah. So to overcome this problem, they are implemented skip list. The skip list name itself we can understand. List is nothing but again here linked list only. Skip means you are going to skip in middle some of the nodes. Then you can skip something. No need to go with sequential order. Sometimes if it is required, you can skip some of the nodes. When you are skipping means some comparisons are going to reduce or not. For example, here from here I am going to skip directly. I want to move like this 7, 1 to 7. Now I am going to skip how many nodes here?
2 nodes.
If I am skipping means my comparison time is going to reduce or not.
Yes, sir.
Yes, sir.
Even my time complexity also going to reduce or not.
Yes, it is.
So this is the idea. Then how to skip and what we should skip, I will tell you. But the skip is nothing but here you can connect instead of connecting next node, you are going to connect after some nodes also. That is what exactly the skip list mechanism. Clear? Idea is clear now? I will tell you how to connect. I will tell you. Clear?
Yes, sir.
Yeah. Yeah, simple 2 lines I will read. Skip list is a variant list for the linked list. Skip lists are made up of a series of nodes connected one after the other. Each node contain a key and value. Same thing like dictionary I told you in a sorted chain, same way. Each node contain a key and value. You know, when you are going to use dictionary, compulsory key must be there along with the value. It is very important you remember, as well as one or more references. This point you must be remember. One or more reference means here every node is divided into 3 parts. Basically, that one part is for key, data, and linking to the next part. That link again we have more references, more links. We have to do it. Here, how to do it, I will tell you. Are pointers. Okay, references are pointers to nodes further along in the list. The number of references each node contains is determined randomly. I will tell you how. Here, the basic representation I am showing. Node is divided into how many parts here? Actually, sir, I have not taken data part. You take it data part also, right? Sir, node is in this case, node is divided into 1, 2, 3. 1, 2, 3, and 4. So as per the requirement, that's why the implementation of the program is more complex here. So that is why I am not written any program. If you want, I will tell you later, because in theory syllabus they are not given, and laboratory syllabus also they are not mentioned implementation of the program. But theoretically you can understand, you can write. Now, so this is for key, correct? Are you clear? Hello.
Yes, sir.
This is for data. This is for link connecting to the next node. Along with that, some more references are required. One or more references. That is up to you. I have taken only extra one reference. It means extra reference means extra pointer to skip next connecting node. So whatever the node I connected from here I am using one more extra pointer to skip the next connecting node and connect its next following node. Understand? Means in this representation, there only one node I am skipping. Are you clear this? How it will work, I will tell you, don't worry. First of all, understand the basic structure. So generally, linked list, how we are connected in a dictionary? This node, key, data, and link to the next node. Key, data, link to the next node. Key, data, link to the next node. Key, data, link to the next node. Like that we have to use. But in a skip list, along with this linear structure, this is the linear structure, means one node connected to another, one node connected to another node, one node connected to another. This is a common structure, compulsory. It is base. After this base structure, here if you wanted to skip this base structure, here we can skip in middle nodes, or if you skip 2 nodes, 3 nodes, 4 nodes, that is up to you as per your requirement. In this example, I shown only skipping of one node, means use one more pointer to skip that particular nodes in between or single node in between. Are you clear for this idea? Are you clear? Skip means we have to store this node address into here. That is what exactly in this pointer. So how to move, how to do, I will tell you. Idea is clear now? Here anyway, last node, this is going to point to null only. You know very well. I cannot tell much. You can understand. Correct? Correct.
Yes, sir.
Yeah, you know, in this skip list, the first node is called as head node, the last node is called as tail node. This is common. It is going to point, next node is null. Okay. Now, sir, I will show you one example, then you can understand here. Sir, now come to the point. Everywhere data part is there. I am not considering more about data part because it is common, right? We don't think about the data. Are you clear? Don't feel, sir, you are not written data part. Okay, this is common. That's why I don't want to write it. We don't want to. We have to store data only, but logic only based on keys only, right? Sir, no.
Yes, sir.
Yeah, the basic level, if you are going to observe, what is the basic level? That the node is divided into 3 parts. Now, one is key part, data part, and another one is the connecting to the next node. So this is a linear data structure, and as well as it is a dictionary. It is a sorted dictionary. Again, I will tell you, it is a sorted dictionary. 2, 10, 15. Sorted dictionary or not? So green lines, you follow green lines. Whatever I am drawing, green lines only you follow. Correct? 31, then 71, then 96, then null. Correct? Please follow this green line. This is a dictionary or not? Sorted dictionary, sorted chain dictionary or not? Is this sorted chain dictionary or not? Hello?
It is, sir.
Yeah. Now we are going to make it. When we use this, Here the time complexity is big O of n only. That means how many number of nodes are there, that many comparisons are required. To overcome this problem, here the skip list is required. Here I have taken, this is a perfect skip list. This is a perfect skip list. Here in between every node I want to skip. Here in between every node, okay, between node, middle node I want to skip. That is called as perfect skip list. Here depending on the requirement, I want to skip 5 nodes at a time also we can skip it. That is as per the requirement. Now the perfect skip list is only in between one node we are going to skip. Here further, here we need along with this pointer, the node is having again first initially one pointer. This is only right. Here now one pointer I need. Then again we have to add it. Okay, pointer is added. Then what should we do to connect to whom? To connect after skipping of next node. Here we are connected this. Only one node you have to skip this. Okay, this is a one level. Okay, please. This is node one level only. Here in this case, up to blue line, it is level one. Node level one. Now, here again, after reaching this 15, again, it is a linear structure. Again, I want to skip from here one node because one skip and again one skip is required. Then this node is extended with one more level. Okay, it is connected after skipping of this 31. Then again, this 31 is having linear. Again, it wants to connect, skip one node. It is connected to 96. Then after 96, no node is there. That's why it is pointing to 1. So like that, we have to do it. It is very big, challenging task to write up the program, but the implementation is not there for you. Just graphically you can explain, then you can understand. Right. Now, even though I want to skip some more in middle nodes, then I am going to increasing the level. First node only we have to do that. Then later, next nodes we have to skip it. That is what exactly the idea. From first node only we have to do it. Again, I want to skip some more nodes. Then skip the in middle nodes. Then when I am going to do that, what happens? You have to skip. Anyway, you are skipped this already. No need to connect this. Here now you want to skip this. Anyway, you are already skipped this. So that's why you have to skip all these three. Then it is connected to 31. Now this 31 also wanted to skip. Here anyway already it is skipped 31. And this now you wanted to skip. Now next there is no node. That's why here this directly is skipping and moving to null. Here means if it is extended some more nodes, it is going to continuously extending. This is level 3. Here level 4, level 5, like that we can skip. Level 3 means we are skipping. For level 3, if you observe, when I am moving this reference level 3, here how many nodes are we are skipping? 1, 2, 3. Yes or no? Yes or no? Hello?
Yes, sir.
Here like that, if you are going to do more number of nodes, you can increase your levels. Here that many number of nodes you can skip at a time. Are you clear? Understood? The structure is understood everyone. Is the structure is understood everyone? Here, this, why it is perfect skip? The meaning is here number of reference levels are there in the node. That many number of nodes we are skipping. That's why it is a perfect skip. But here other skips, if we want to implement, here I am going to do only 2 levels. I wanted to skip 10 nodes. That is not a perfect skip, but you can implement it. Understand? It is as per the requirement, as per the client requirement, as per your program requirement. Understand this? Please ask me any doubt here. Clear? Clear? Hello?
Yes, sir. Clear.
If it is clear, now then when I wanted to search one element, for example, I wanted to search 71. If I wanted to search 71. Here now earlier I told you if you go with sorted linear structure for a dictionary implementation, it will take big O of n. But when you go to in the skip list, I wanted to set to 71. Generally, big O of n, how we will tell 1, 2, 3, 4, 5, 6, 7. You will tell 7 only. But come to 71, it is going to reduce, that is big O of log n. How I will tell you? Big O of log n is the time complexity of the given perfect skip list. How it is, I will tell you. The 71 I wanted to search. Now tell me. Now 71, always you have to work from start only, correct? Please carefully understand, then only you can understand whatever I am telling. Here 71. Here 2 and 70. Key is 71, right? Now 2 is the key. Now compare. Which one is the greater? Which one is the greater? Hello?
71.
Here 71 is the greater. Then move to the next level. Clear? Clear?
Yes, sir.
Sir.
Then go forward direction. Now compare with 15. Which one is the greater? Which one is the
71.
greater? Huh? 71.
71.
Yes. Now go forward direction. Which one is the greater?
71.
71 is the greater. Now if you want to go up, no level. Yes or no? Then first comparison. Yes or no? There is no up level, right? Only one, 2, 3 only, right? 3 is over, right? Yes or no?
Yes, sir.
Okay.
Now from this 31, here which one is the 71? Then it moves to the come down. When it moves to the 71. Now how many comparisons? 2 comparisons. Understand? Here 1, here 2. Are you clear? Here visiting nodes. We are visiting nodes here. Here 1, here 2. Are you clear?
Yes, sir.
Are you clear?
Yes, sir.
Sir, now just if you use linear structure, how many comparisons we have to visit? 1, 2, 3, 4, 5, 6. Yes or no? Yes or no?
Yes, sir. Yes.
Yes, sir.
Now I will tell you. I wanted to search 100 now. Now go to the linear structure. How many comparisons? 1, 2, 3, 4, 5, 6, 7. Means you know big O of n. Yes or no? Yes or no?
Yes, sir. Yes.
Yeah. If we use skip list, what happened? Here 71, 2. Sorry, 100, 2. Then go to the up. Correct? Then go to the up. Correct? There is no up. Then go to the 31. Then how many comparisons? 1 and 2 comparisons we are going to tell the 100 is not there in this list. Yes or no? Yes or no?
Yes, sir. Yes.
If it is like that 1000 elements if you are going to accommodate, then you can imagine how much amount it is going to reduce. Here, then how we are going to calculate big O of log n? What is the meaning? I will tell you. Here, what is the n value? N value is number of nodes. How many nodes are there here? How many number of nodes are there here? Don't tell these references, please.
7, sir.
7. Here means log 7. Log 7 means base 2 is there defaultly. Here 7 means we cannot calculate, you can make it 8. Just. Correct? Now tell me what is the value? Log 8 base 2. Instead of 7, I am taking 8. Log 8 base 2. How much? Hello? Hello? 2 table. Log 8 base 2. What is the value? Log 8 base 2. What is the value? Yeah. Default means value is 2. Log if you write base 2 only. Tell me. What is the value? Oh, you don't have that knowledge.
Sir, 3, sir.
Yeah, 2 2s are 4, 4 2s are 8, 2 power 3. The 3 will come front of the log. Log 3 log base 2, 3 log 2 base 2, then 1, then 3. Correct? Correct? Hello?
Yes, sir. Yes, sir.
The meaning is big O of 3 in this case. Big O of log n means, in this case, big O of log 3. Means whatever the element, if we want to if we wanted to find any element in this particular skip list, it will take maximum 3 comparisons. Within 3 comparisons, it will tell. Understand now? Sure, you are verified 100, you are verified 71. Both are not taking more than 3 comparisons. Is it true or false? Is it true or false? Hello? Hello?
Yes, sir. Yes, sir.
Yeah. So now the perfect skip list time complexity is what? Big O of log n. Please, people will ask these questions in assignments, placements, gate examination. What is the time complexity of skip list, perfect skip list? Your answer is big O of log n. Understand? Understand?
Yes, sir.
Yeah.
Yes.
Coming to the operations, fast, very fast, quickly we will do that because it is only graphical presentation. Because there is no implementation, they are only asked you representations. Right. Here, when you are going to perform skip list operations, okay, you know, search, delete, insert, and display. These are the operations, you know. When you are going to perform any operation in a skip list, you have to do search operation. This is a default operation because when you want to insert also, you have to find the appropriate position. When you want to delete also, you have to find the appropriate node with help of search operation. Correct? That's why I'm doing search operation first. Correct? Correct. For example, 31 I want to delete. Then I want to find the 31 or not. How to find it? How to search it? Yes or no?
Yes, sir.
So that's why the search operation I'm discussing. For this search operation, you must be remember these 3 important points. Then you can understand whatever I explained just now. Same thing I have written some points. If k equal to key, here k is nothing but your value, whatever the value you are going to search. Here that is equal to key, then done. Means when it is reached to k equal to key, then your search is done. Otherwise, if k is less than next key, k is less than next key, go down a level. Here you must go down a level. If k is greater than or equal to next key, if your key searching element is greater than or equal to next key, then go right, means move to the right side. Okay, we'll do that same process. Now I want to find 71. This is a k now. Okay, in this particular skip list, here you know, here we have taken 4 levels. This is not a perfect skip list because here I have taken different skips. Correct? Observe that. Is it right? Hello?
Yes, sir.
Yes, sir.
The comparison time is what? Big O of log n. Big O of log n. Big O of log n means how many number of nodes are there here? Tell me.
10, sir.
10. Tell me big O of log 10 base 2. What is the value? Approximate at least. You take, this is 10, right? You take 16. What is the wrong? 10 elements are there, right? Then you can take it as 16 because there is no near number, right? And then tell me what is the value? Hello?
4.
What is the value? 2 table, yeah. 2 2 ja 4, 4 2 ja
4.
4 only.
Right.
Actually not 4, but we are taking 4, correct? Yes or no? Yes or no? You people are, hello?
Yes, sir. Yes.
Yes, sir.
Yeah, we are just shifted 10 to 16. Just 4 we have taken 16, then 4. Here means maximum 4 comparisons we can find that particular 71 is existed or not. Right. Now from where we have to start? From beginning we have to start. Now tell me 71 with 2. It is greater than up, correct? Yes or no?
Yes, sir.
So like that, sure, you are moving. What happened? 71 and 76. Which is the greater?
76.
76 is the greater. Then what should we do? You have to go down. This is a statement. Means you go down. From here we have to do it. That means you come to this node. This is first comparison. This is second comparison. Yes or no? Now 31, 71. Which is the greater? 71. Then move to down, right? And move to 71. This is third comparison. Yes, 71 we found. Are you clear?
Yes, sir.
Yes,
Now
sir.
if we want to find 96. Now tell me, from 96, what happened? It moves from here to here. Which one is the greater? Which one is the greater? Hello? Which one is the greater? 96 is greater. Then move to its next. There is no node. Yes or no?
Yes, sir.
Yes, sir.
If there is no node, you must go to down. Here also no node. Go to down. Now again compare. The first comparison is over. Again compare. Now 96, 91. Which one is the greater?
96.
96 is the greater. Means you must move here. Yes or no? Then here no node. Means it is what? Second comparison. Come down. Next move to down and move to here. Here next compare here. Equal, right? This is the third comparison. Are you clear?
Yes, sir.
అప్పటికప్పుడు
క్రియేట్ చేసిన
Sorry? Sorry? Tell me.
Yes, sir, nothing.
Okay. Here now, here for given any time, it never exceed big O of log n for this skip list. Yeah, this is the idea. But implementation is more complex. Implementation is more complex, but this is the idea. Now insertion. For example, I want to insert 87 in this skip list. This is the skip list. Here I want to insert 87. Then we have to find the appropriate location. Here, again, you have to search it. Here 87. You have to search it. 87. Here from where? 87. Tell me from here 87. Now it is going to compare with 76. Here 87 is greater or 76 is greater?
87.
Your first comparison and move down again null. Then it moved on. Now it will compare with 91. Here which one is the greater? 87,
91.
91. Then again move down. Then compare with the next node. 87 and 86. Now 86 will be moved. Then you have to move next node. Yes or no? Here what is this? 91. Here 87. Now which one is the greater? 91 is the greater. Means you have to connect 87 before 91. Yes or no? Yes or no?
Yes, sir.
Okay, that's why here 87 is inserted before 97. So while inserting, you have to check with the skip list. Same way, we have to use here. Actually, what happened? 86, only 2 levels are there. But here, after 86, we have to insert 87. Compulsory that 87 also must contains 2 levels. The same, whatever the order is there, same order, it will comes to 87. And next element, whatever it is there, 91 is going to appear as a 96 order. Means only one order. 91 is one order. And the 96 will go 3 levels. So what order? First order means 1 level, 2 level, 1 level, again 3 level. Same way, 1 level, 2 level, 1 level, 3 level. So this implementation is very complex, but graphically you can understand. Clear? This insertion is clear? Clear?
Yes, sir.
Comes to the here practice. Here practice, it will help a lot. Here deletion, I will stop the things. Here deletion. Here when you want to delete any element, here then you have to search it. You know very well. You want to delete 76. You want to delete 76. Again, you have to move from here to here. Here only one comparison. You got it. Yes or no?
Yes, sir.
Now you are going to delete this node. After deleting, what happened? This node comes to this position. This node comes to this position. This node comes to this position. Means 86 comes to 4 level. 87 comes to 1 level. 91 comes to 2 level. And 96 comes to 1 level. Correct? Correct? Yes or no?
Yes, sir.
Yeah, so this is the idea. Okay, this is the idea. This is the representation only they are given. Even though I provided program, but it is very tough program. If time permits or anything is there, we will do that. Okay. Now understood this? I will share this PDF to your WhatsApp group. Please try to practice and try to work out of this graphically. Anything is there in the next class, we will discuss. At least you understood today exactly.